Some discoveries are made in a flash of inspiration. Others require sifting through miles of paper, looking for a single anomaly. In the late 1960s, at the University of Cambridge, a young PhD student named Jocelyn Bell Burnell did just that, and she found it. A bit of scruff, she called it, a signal so strange its origin was jokingly coded. LGM for Little Green Men. But what she had actually found was one of the most important astrophysical objects ever discovered. And the controversy over who should get the credit would ignite a debate about science, credit, and bias that still resonates today. It was the pulsar she couldn't claim. To understand the discovery, you must first understand the instrument. It was a new type of radio telescope designed to track the flicker of distant quasars. The environment was also intensely competitive. As a young woman in physics at Cambridge in the 1960s, Jocelyn Bell was a notable exception. Her place here was already a testament to her resolve. Her doctoral project was to help build and operate a massive new radio telescope. Nearly 200 wooden posts, over 100 miles of wire and cable. It was engineered for a specific purpose, to study known quasars by measuring how their radio waves twinkled. This made it exquisitely sensitive to small, point-like sources of radio waves, a capability that would prove fateful. This was not abstract science, it was physical labor. As Jocelyn would later say, we built it with our own hands. We were not afraid to wield a spanner. With the telescope built, her task began: operate it and analyze its output. The data did not come on a screen. It printed as a continuous line on rolls of paper. 400 feet of chart every day, 100 feet for each of the telescope's 4 beams. Week after week, the paper accumulated. Her world became this endless, inky line. To find a new signal was not like finding a needle in a haystack. It was like finding a single, unique stitch in a mile of knitted fabric. Her job was to examine every inch by eye and by ruler. It was monotonous, it was meticulous, it was the unglamorous foundation of the entire project. And then, after months, she saw it. A tiny, peculiar pattern, a regular pulse, buried in the cosmic noise. Even after seeing it, doubt lingered. Was it an artifact? Her training demanded rigor. She repeatedly verified the timing, cross-referenced logs, and eliminated every earthly explanation. The signal was unlike any known natural radio source. Its staggering regularity, one pulse every 1.337 seconds, was unprecedented. The team's first, half-serious thought was the unthinkable. Had they detected an artificial signal? They labeled it LGM for Little Green Men, a private joke born of sheer bewilderment. They checked the equipment, ruled out interference, satellites, and radar. The signal was real, and from deep space. Jocelyn soon found a second, similar source. Why was this monumental? Theorists had predicted neutron stars, the fantastically dense corpses of supernovae, but they were considered mathematical phantoms. Jocelyn Bell's Scruff was the first direct proof they were real. The answer was a pulsar, a neutron star spinning at incredible speed and beaming radiation like a cosmic lighthouse, a theoretical prediction made stunningly real. The mood in the lab was electric, but tempered with extreme caution. They knew they had seemingly found an entirely new class of celestial object. The discovery was published in Nature in February 1968. It was a seismic event. The paper bore her name, S. J. Bell. The scientific world now knew of pulsars, and it knew who had found them. The announcement of pulsars was a sensation. It solved a mystery and opened 100 more. What were the limits of their density? How were they born? The press was captivated. The astronomical community mobilized globally, searching for more. Within a year, dozens of pulsars were found. A new field of astrophysics was born overnight. As the co-discoverer, Jocelyn Bell was at the center of it. She completed her PhD, titled The Measurement of Radio Source Diameters Using a Diffraction Method, which detailed the technique that made the discovery possible. Her focus remained on the rigorous science. In October of 1974, the Nobel Committee made its decision. The highest honor in science would recognize the discovery of pulsars. The prize was awarded jointly to Anthony Hewish, her supervisor, and Martin Ryle, the head of the radio astronomy lab. The citation credited Hewish for his decisive role. Jocelyn Bell Burnell's name was absent. The student who built the instrument, operated it, analyzed the data, and first identified the anomaly was not included. The decision was immediately controversial. Prominent scientists, most notably the cosmologist Fred Hoyle, publicly decried the oversight. Within scientific circles, it sparked fierce debate that has never fully ceased. The prevailing argument of the time followed a strict hierarchy. The Nobel honors the leader of the lab, the person who conceived the experiment and bore the ultimate responsibility. The student is the hands, the professor is the mind. The discovery is seen as the fruit of the tree he planted, but this view fractures under scrutiny. Conception and execution are both decisive. Without Hewish's design, there is no telescope. Without Bell's exhaustive labor and singular perception, there is no discovery. The history of science, however, has persistently undervalued the latter, especially when the hands doing the work belong to a woman. Publicly, Jocelyn Bell Burnell was the picture of grace. She never publicly expressed bitterness. In a now famous statement, she deflected, "I believe it would demean Nobel Prizes if they were awarded to research students. It is the supervisor who has the final responsibility." This was not an admission of unworthiness. It was a statement of the institutional reality she understood all too well, delivered with a diplomat's skill. It was a choice to rise above the controversy, but it did not change the fact of the omission. The personal and professional cost, however, was real. While Hewish's career was cemented, Bell Burnell's path was less straightforward. She left radio astronomy for a time, moving into other fields, like gamma-ray astronomy, and raising a family, navigating a career landscape that was far less clear for a woman who had just been passed over by the Nobel Committee. Jocelyn Bell Burnell's story was not unique. It fit a pattern where the work of women and junior researchers was systematically absorbed into the credit of senior, often male, lab heads. This pattern is often referred to as the Matilda effect. Jocelyn Bell Burnell's case simply became the most famous example in the physical sciences. So, the question history leaves us with is not about the validity of the discovery, which was rock solid. It is a question of credit. In the search for truth, do we reward the architect of the lab or the one who actually sees the signal? In 1974, the Nobel Committee made its choice, and in doing so, it created a legacy for Jocelyn Bell Burnell that would become about far more than a prize. If the story ended in 1974, it would be one of brilliant work and institutional oversight. But Jocelyn Bell Burnell's story was unfinished. What she built from that moment defines her legacy far more than any prize. She forged an exemplary career on her own terms. She became a renowned professor, a sought-after science communicator, and a trailblazing leader, presiding over Britain's most prestigious scientific societies. She had earned respect and authority entirely in her own name. Meanwhile, her pulsars revolutionized astronomy. They became nature's most precise tools. The 1993 Nobel was awarded for using a binary pulsar to give the first indirect proof of Einstein's gravitational waves. Today, networks of pulsars are used to hunt for those waves directly and could one day serve as a galactic positioning system for spacecraft. 50 years after the discovery, the scientific world made a profound correction. In 2018, Jocelyn Bell Burnell was awarded the Special Breakthrough Prize in Fundamental Physics. The citation was unequivocal. It honored her for the discovery and for her lifetime of leadership. The award carried a $3 million prize. Then, she made a decision that stunned the world and cemented her legacy. She announced she would donate the entire $3 million prize fund. Her reasoning was simple, powerful, and personal. The money, she said, should be used to create opportunities, not for personal luxury. She said, "I don't want a sports car or a yacht. I want to make a difference. I don't want to waste money." I found that going through the experience of being a winner takes a bit of getting used to, frankly. She created the Bell Burnell Scholarship Fund. Its mission was explicit: to fund graduate students in physics from groups historically underrepresented in the field: women, ethnic minorities, and refugees. The poetic justice was breathtaking. The funds from a major prize, awarded late for the discovery she was once overlooked for, would now be used to dismantle the very system of bias that led to that oversight. She transformed exclusion into inclusion. Her action sent a seismic message through science. It wasn't just about money, it was about validation, access, and changing the face of who gets to be a physicist. It ensured that her discovery would not just illuminate the cosmos, but also light the path for generations of future discoverers who might otherwise have been left in the dark. For what it's worth, history has rendered its verdict. The pulsar is remembered as one of the great discoveries of 20th century science. And Jocelyn Bell Burnell is remembered not for a prize she didn't get, but for the profound grace and transformative leadership she showed in response. Her story tells us that the true measure of a discovery isn't just the new truth it reveals about the universe. It's also the new truth it forces us to see about ourselves, who we value, who we overlook, and how we can choose to do better. She took a signal from the void and turned it into a signal for change. And in doing so, she didn't just claim a pulsar. She reclaimed the narrative of her own science for the benefit of all science. From a bit of scruff on a chart to a beacon for change in science. That is the journey of Jocelyn Bell Burnell. If stories of curiosity, persistence, and truth matter to you, help us tell more of them. Subscribe to the channel, leave a like if you were moved, and be sure to tap that notification bell. We're here every day and every week at the intersection of what we know and what we don't. There are always more forgotten defenders and more cosmic mysteries just ahead. This has been For What It's Worth.